In this video we will solve an initial value problem for vector functions. So remember, an initial value problem is something of this form. You're given the derivative of a function and something that we call the initial condition, which is this right here. Now, to solve initial value problems, we need to integrate, since we're given the derivative of the desired function. And what the initial condition does is it allows us to find the constant of integration after integrating. So let's go ahead and do that. So if this is r prime, we want to find r. R is the antiderivative of r prime, and so r is the integral of r prime. So in other words, to get r, we just take the integral of each of the three components of r prime. So first the x component, 10t plus 5. If we integrate that, we get 5t squared plus 5t. Second, the y-coordinate is just 2 for r prime. If we integrate 2, we just get 2t. And finally, 12 square root of t. If you integrate that, you get 8t to the 3/2 power. And hopefully, right now, you notice that I forgot something very important. Whenever you do an integral, you get a constant of integration. Like, you always get a plus c, plus some constant. And we did 3 different integrals here, so really I should have put a plus c after each of the 3 components that we did. So I'll just write them in a separate vector. I'll call the first one c1, the second one c2, and the third one c3. So again, these are just the constants from doing the 3 integrals. Now maybe let's rewrite this a little bit. We can factor the first part, make it look a little cleaner maybe. Factor out 5t, write it as 5t times t plus 1. And maybe let's put it all together, put plus c1. And then here, 2t plus c2, and 8t to the 3/2 plus c3. So we're most of the way there. We know generally what the function r looks like. But to actually be done and have our final answer, we need to find what these 3 constants are. And that's where we use the initial condition. So we're told what values we should get when we plug in 4. So let's just check it. So when we plug in 4, what happens? So here we get 5 times 4 is 20. Times 4 plus 1 is 100. So 100 plus c1. If we plug in 4, this is 8. And if we plug in 4, let's see, what's 4 to the 3/2? The square root of 4 is 2, and then cubed is 8. So 8 times 8 is 64. Okay, so using our answer above, if we plug in 4, this is what we get. And the initial condition is telling us that we should choose the constants so that this is equal to 100, 10, 68. So the first component, the x component, is already 100. So that tells us that c1 should be 0. The second component, we want it to be 10. We have 8 plus c2, so c2 should be 2. third for the z component, we want it to be 68. 64 plus c3, so c3 should be 4 in order to make that 68. And now we're done. So let's just rewrite the answer above, but now with the constants that we found. So our final answer here is that the function r of t is 5t times t plus 1 plus 0, 2t plus 2, and 8t to the 3/2 power plus 4.